Welcome to part 3 of the video for chapter 3. Today we're going to be talking about variance, and we touched on it in the last video, but I wanted to give you a better idea of what the variance is, how we calculate it, and why it's important. So the variance looks at the average distance the attributes have from the mean. So going back to our test scores, we had 82% was the mean. We want to know what the average distance from all the other people that took the test, how far away are they from this 82%? And why that's important is it gives you an idea of the range of your test scores. For example, it could be the lowest was 72 and the highest was 93. And that would show very small variability, meaning that there wasn't a very big difference between the mean and the other test scores, if that makes sense. If you have a large variability or large variance, let's say this score would be 36 and this one would be, let's say there's extra credit at 103. So there's a wider range of variability within this variable. So it helps show what is going on with the variable, and is this a very good descriptor of your overall variable. If there's a lot of variance, it's not going to be a very good descriptor because the scores are going to be a lot different from 82 compared if there's smaller variance. Okay, so let's go and talk about how we would calculate the variance. Okay, so turn with me to page number 57. Here's a very good example in your book. So they have these values here. So 1, 2, 3, 4, 5 here, just like in there. So the first thing you have to do is find out how far away are each of these attributes from the mean. So we need to find out what the mean is. So 1 through 5 added up is 15, divided by 5, because there's 5 attributes. So the mean would be 3. So then we have to go and divide or minus 3 from all of these attributes to see how far away from the mean they are. So we're just going to go minus 3. Okay, and that means this is negative 2, negative 1, 0, 1, and 2. Now, if we wanted to just add these together, we would end up with a total of 0 because we're finding the difference between the mean, which means since it's in the middle, there's going to be negative numbers and positive numbers for here. And we don't want numbers to cancel each other out. We want to find out what the real differences are. So what you do is you square it, because squaring it gets rid of all of the negative signs there. So then we're here with 4, 1, 0, 1, and 4. So if you add those up, you get 10. Now if you look at step 3 in your book, it says after you find the sum of squares, then you divide it by the number of attributes. And here it says, if you're looking at the population, you use just the number of attributes. If you're looking at a sample, then you do -1. Now, let's talk about what is the difference between a population and a sample, so that's a little more clear. So the population is the whole group of people that you're looking at. So let's say I'm interested in the class's satisfaction with my teaching, and I'm only interested in you guys, my class. So the class would be my population. Okay? I'm not interested in inferring this to someone else, just the population. So then I would just divide this by 5. Okay? No big deal. But if I'm interested in, say, I want to know how students tend to feel, not just you guys, but all of my students I've ever had and I'm going to have my students. So if all of my students are the population, you guys would just be the sample right here, because you just be a small portion of my population. So since I'm using your data to infer how the population probably would feel, I would need to -1. And I could go into why we do -1, but it gets into a little bit more statistical analyses than I want to get into right now. That's a little farther ahead of where we are. But just now you would -1 if it's a sample. You would not minus 1 if we're doing a population. Let's say I'm just doing the population. I'm only interested in you guys and how you guys feel. So then I would just do 10 divided by 5, which is 2. So the variance would equal 2. Now that's great. That's great to know. 2 is not too crazy of a number. That means it's kind of representative of, you know, the mean is pretty representative. It's pretty good. Now we have a problem because we have squared these numbers, which means that it's not on the same level of measurement as our original data over here. So we want to make sure that it's the same. So what we do to find it, which is called the standard deviation, is we need to square root our answer, which is just reversing this process here. So if we square rooted 2, that would be the standard deviation, which would be 1.41. So with standard deviation, variance plays a large role as we move forward in the class. So it's important to understand what these mean, how we come about these answers. So let's just do one more very short example to kind of solidify one point. So the sum of squares, the variance, the standard deviation, these are all tools to help us know, as we've said before, is the mean a very good fit for our data? Is it very representative? So if we had a test score, 82, and the standard deviation here, let's say was 1.3. That's relatively low. That's showing, you know, this is probably a good indicator that this is representative, meaning that the attributes tend to cluster around 82. Let's say it was 73 and 94. So it's pretty close, pretty representative. We have a tight-knit group of attributes that don't have a lot of variability. And in the second course, average was 82, but let's say the standard deviation here was 9.3. Now this means that there's a lot more variability in these test scores, meaning that the lowest ones, let's say it's 61, actually we'll change that, we'll say it's 51 and 100%. So here there's going to be a lot more variability or variation within your data. So it kind of gives you at a glance what your data might kind of look like, how much variation is in the data. So it's just another tool to give people an idea of what your data actually looks like. So if you guys have any questions, please email me. I hope these videos are helpful to you. I want you to be successful. So if you have any questions, let me know.